So for today's lesson, we're going to do compound locus. So you should know the 5 basic loci from yesterday. And then compound locus is just still locus of points, but it's going to be a locus of points that satisfies 2 or more conditions at the same time. When you try to find points that satisfy a compound locus, you need to make sure that you draw whatever diagram you can that contains the given data, fixed lines, and or points. You're then not really so much going to construct, you're going to sketch because we're not going to be so accurate. We don't use a compass or anything here, so you're really going to be sketching the locus of points for each condition on the same diagram. It's pretty helpful to use a grid, and I'll give you some graph paper, but you might want to use your own. You're going to clearly label each locus, and you're going to mark the points where the loci intersect, and these points will satisfy both sets of conditions. So here's how it works. So for each of the following, be sure to sketch and describe the locus. Point A is on line L. Find the locus of points 2 centimeters from L and 3 centimeters from point A. Well, what's given to you is this. Anything that's given should be written in solid. Okay, so we need to then draw point A on line L, which means anywhere on this grid, you're going to draw a line. Because we're drawing, because it's a line, we want to make sure that, I'm sorry, because it's a given, I apologize, you need to make sure that it's a solid. Okay, so we've got a solid line here. Don't worry about this little extra blip over here. I don't really know what's going on here. Let's delete this. Okay, so there we've got our line L, and we're going to label it as such. And then point A is on line L. It doesn't tell you where to put point A, so you put it anywhere you want. I'm going to put A right here. We've got 2 conditions. The first condition is we want to find the locus of points 2 centimeters from L. Well, if you're 2 centimeters from L, you're going to be 2 lines that are parallel to what's given. We're going to use each box, and we're going to call that like a centimeter. The fact that we're drawing a locus, the locus that we're drawing is a dotted locus, so that's 2 centimeters from L. Then we want to be 3 centimeters from point A. Well, from a point, you're going to have to be a circle. So 3 centimeters from point A, I'm going to go up with a radius of 3 here, a radius of 3 here, radius of 3, and I'm going to draw as best as I can. It's not going to be perfect, but a circle. As it turns out, the 2 loci intersect in 4 places. They intersect here, 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 and here. So the answer is the loci are 4 points. If you want to label those points A, B, C, and D, that's fine. So this is enough for the answer, but what I would like for you to do is to extend this a little bit, and you can just say the loci come from the intersection of 2 parallel lines and a circle. Now, you don't have to write that parentheses at this point. It's fine to say the loci are 4 points, but it'd be nice if you can extend and explain what you drew and why you knew what to draw that because of the line and the point, and then go for your answer. Okay, so make sure this is good. It's 4 points. I've marked them off. If you want to label the points, you can, but these X's are fine and your explanation is fine. Okay. Point C is 7 centimeters from line M. We want 1.7 centimeters. You can go on either side of the line that you draw. It doesn't matter, but it's only 1 point. Find the locus of points 5 centimeters from M and 3 centimeters from point C. Well, just because I know what this problem looks like, I'm going to draw a line that happens to be a vertical line. And I'm going to go somewhere about here. Okay, this is my line M. Point C is 7 centimeters. So somewhere I'm going to go to the right. I'm going to go 7 centimeters. 1, 2, 3, 4, 5, 6. So here's my point C. This is all given. Find the locus of points. Okay, 5 centimeters from M. That's one condition. 3 centimeters from C. That's the other condition. Alrighty, so if I'm 5 centimeters from M, I'm 2 lines on either side of M, 5 centimeters away. 1, 2, 3, 4, 5. So this would be one of the lines, this would be the other line. That takes care of the first condition. The second condition, 3 centimeters from the point C. 3 centimeters away is going to be a circle with a radius of 3. Do the loci intersect? And they do, and they intersect right here. So here the locus or the loci is 2 points. Okay? If you want to get fancy again, you can write it from the intersection of the circle and the 2 parallel lines. Find the locus of points equally distant from 3 non-collinear points, A, B, and C. So non-collinear. So what ends up happening is I'm going to draw 3 points. I'm going to draw A here, I'm going to draw B here, and I'm going to draw C, I guess, over here. These are considered to be points not on the same line, non-collinear. So the idea is, how am I going to find the intersection of those points? Well, I can but I can connect these 2 points together, and I can say, well, the locus of points equally distant from those two is going to be any point that's on the perpendicular bisector. So if I can find the middle of this point, and I can draw the perpendicular bisector from AB, and now I'm going to connect, it doesn't matter where you go, I'm going to connect, in this case, I'll connect B to C. Well, maybe let's go A to C, that might be easier. So if I actually connect these guys together, and now I do the perpendicular bisector of these 2 points, the locus of points that's equally distant will be this point right here. So the loci is 1 point, which is the intersection of the perpendicular bisectors of AB and AC. Okay. This next one, don't worry about it. To fix that one a little bit. So this should be enough then to be able to do the homework. Good luck.